Hi, my name is Alexandra Hoya. I'm from EC31 of De La Salle University, Das Marinas, and today I'm going to do experiment 1 for our power electronics subject entitled Introduction to Circuit Modeling. So for experiment 1, it is entitled Introduction to Circuit Modeling. So there are three objectives in this experiment. The first is to familiarize with the PSpice simulation software, to capture diagram of switching circuit, to model the switch based on the set parameters. So for the procedures, the first part of the procedure is voltage controlled switch in PSpice. The first step is to open ORCAD and click New Project. So to do that, click Start, type ORCAD, click ORCAD, wait for the application to open, and then we should select New Project here. And then name it Experiment 1. Okay. Create a blank project. Okay. And then the second step we already did those. So the next step is to put the switch. So to do that, uh, click place PSpice component and search, and then type SBRIC, and then double click and put it there. And then the next step is to edit the switch model with these parameters. So to do that, we should go back to ORCAD and double click on SBRIC and then edit PSpice model, and then this pop-up window should appear, and then edit the R on with 0.001, and then click File, Save, and then close the pop-up menu. Next, step 7 to 9 is all about constructing the circuit. So we'll just scroll down to the circuit so we could copy it. So this is the circuit. So what you're going to do is place PSpice component, source, voltage source, and then pulse, and place it here. And then place another component, source again, voltage source, DC, and right here. And then, of course, our resistor, and we should now be able to wait. Let me just okay. So let's change the labels for this. This is VS. And this one is 24 volts. The value for the voltage pulse should be changed. This one is 0. B2 is 5. This one is 0. This one is 1 nano. 1 nano also. 10 micro. And 25 micro. And then this circuit is complete, and of course, this one pa pala, P control. And this one is R load. I almost forgot. And then that's complete. We should wire it now. Wiring the circuit. Okay. And after that, we're good to go. So, oh, don't forget the ground pala. Also here. And now we're good to go to simulate. Okay, create. And then the pop-up menu should appear, and change this to 80 micro, because I think that's what the PDF says. Okay, now we simulate, and the pop-up window should appear, and what we will do is to add trace, and this one, P control plus. So as you can see, the simulation says that there is a 5 peak voltage, and one cycle is complete in 25 microseconds. And it can be observed that 10 microseconds is the time where the pulse is on, and beyond that until 25 it is off, just like what is in the V-pulse parameter. So next step is to check for the voltage across our load, and as we can observe, it is in phase with the voltage in the V control. The only difference is the peak is higher. As you can see here, it is around 24 volts. The reason behind this is because there is a voltage supply 24 volts in our circuit. If we are to compare the two voltages, the only difference are their peak voltage values, which are 5 volts and 24 volts, but they are the same with their turn on time, which is 10 microseconds, and they also both lasted 25 within 25 microseconds. So for the next part 2, we're going to change this to a ISG MOSFET. So to do that, wait, let me just delete all the wirings and change this switch to a MOSFET. So let's do the circuit for the figure 2. So we're going to place a resistor here because it needs another one, and let's change this to RG and the value to 10. So this one should also be changed to 12 volts. Okay, next is to place the MOSFET. So we're going to search for the MOSFET, delete that, IRF150. Okay, click this one and then place it here. Then after that, we should just wire it. Okay, connect this here. This one should be connected here. This one is to the R load, and this one here to the R load, and yeah, this one last. This one. Okay, so after that, oops. Okay, after that, you should place ground, of course, here. Just one. Okay. And then create new simulation, experiment 1, part 2. Then we should see this pop-up menu and change this to 80 US microseconds. Apply and OK. And then next is play. After this, we should open this pop-up menu, just like what we did from the previous part of the experiment. Add the trace for the V control, pull the pulse, V times V control colon plus, and here we can observe that the second part of the experiment, the simulation shows the difference between using the S-break and transistor MOSFET component as the switch for the circuit. It can be observed that there is a value of 541 volts. The rise time and the fall time can now easily be seen in the simulation when we use the MOSFET transistor as compared when we use the S-break switch. Here we can observe the rise time and fall time reaches the value of 1 nanosecond, which matches the parameters that we set in the circuit earlier. Also, just like when we use the S-break switch, it can be observed that the rise time lasted for 10 microseconds and turned off for 15 microseconds, which completes the set parameters of 25 microseconds for one cycle. To check for the load resistor voltage, trace, add trace, and this one, I'll just type it. You can see it VR load colon 2, and as you can see here, as we can observe from the results, the load resistor voltage shows that it has a value of 23.541 volts. It can also be observed that it also rises for 10 microseconds and falls for 15 microseconds, which also completes one cycle in 25 microseconds. So also it can be observed that it is in phase with the voltage in the V source earlier. And that's it.
For the conclusion, given the results of the experiment, it can be concluded that there are various types of switches that we can use in a circuit for different applications. Given the results of the experiment, it can be concluded that a transistor like the IRF150 MOSFET is a better choice for a switch because this has the capability to be transparent with the set parameters in the circuit, like the set parameters in the V pulse. This makes it the type of switch where one can observe the circuit more properly. For the recommendation, before doing this experiment, it is essential to first have an idea on how to use the ORCAD and PSPICE application. Also, once you have the knowledge in interpreting the data obtained from the simulation, possible errors encountered in the experiment could be in terms of the construction of the circuit and the interpretation of the data obtained.